Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is sort of an interlude between law of sines topics. It's for the area of a triangle. There's actually two formulas for the area of a triangle in trigonometry. One associated loosely with the law of sines, although you don't actually need the law of sines for it. But in the text that I'm using this semester, that's just where it's kind of stuck. And the other one is definitely built into the law of cosines. You can't avoid it in there. So this will be the first area of a triangle that we'll deal with in trigonometry. So here's the theorem, and we're going to prove it and do an example. They're pretty easy. The area of A of a triangle with side lengths A and B and with included angle theta is A equals 1/2 AB sine of theta. Well, let's go ahead and prove that. Note in the theorem, it does not say that you need this triangle to be a right triangle. So this is for any triangle. And I'm just took the liberty of saying that that's our angle theta. It's included between the sides A and B. So it's between the sides A and B. That's important for this theorem to work. So the side lengths, let me highlight that, have the included angle of theta. So theta is between A and B. Now, I could also mention here, I suppose, that the angle opposite side B is angle B, if you really wanted to know that. The angle opposite side A is angle A, and obviously the angle theta technically is angle C, but nobody really cares about that. And we also happen to know that the area of a triangle is 1/2 base times height. Well, that's pretty old school, right? That's from our pre-algebra. Well, the base here is B, and the height is H, where H is this height here. But I've drawn that altitude such that that's a right triangle. So I wonder if we have a trig function that relates this angle to that height to that length A. And if you said sine, you are absolutely correct. The sine is opposite over hypotenuse. So the sine of theta is H over A. So I'll write that in. Sine of theta is H over A. Or in other words, H is equal to A times the sine of theta. So in our formula for area, which was 1/2 base times height, we could replace that height, which is H, with A times the sine of theta. Or in other words, 1/2 AB sine of theta. And that is what we wanted to prove. That's this formula right here. So QED, the proof is done. Very fast proof. And now to use that is almost as fast, honestly, if somebody asked you to use it. Initially, when you move forward in mathematics and you go into pre-calculus, I have a video on this in pre-calculus, and the problems get a little more dense, a little harder to do. But if you want to challenge yourself, I recommend looking at my pre-calculus video list and seeing that. But let's go ahead and take an example here. Find the area of the triangle with the given measurements. So we have a side length A of 32, side length B of 24, and an angle C of 75 degrees. If you don't draw this, remember I kind of have a habit of not drawing triangles. If you don't draw this, you might risk misinterpreting what angle goes where. So I'm going to quickly sketch out a triangle. I don't really need to use a ruler actually. So I'll say that this is angle C, and it was a 75 degree angle. So something like this, 75 degrees. The side opposite that angle is going to be side C. So now I know that the other two sides are A and B. Doesn't actually matter which one it is. I just now know, oh yeah, the other two sides must be A and B in it. And again, it doesn't matter which one plays the role of the horizontal or which one plays the role of the vertical. So I'll just say the horizontal is B. Having done that, I can use the area formula. The area of this triangle is just 1/2 AB sine of the angle between A and B. And that'll be 1/2. A is 32, B is 24, and sine of the angle between them, which is 75 degrees. And of course, because I do not know offhand the sine of 75 degrees, actually, you know what? If you're going through and watching my lectures in order, let's do this. Let's do this without a calculator, because you totally can. Half of 32 is 16. That wasn't the part I assumed you could do without a calculator. The sine of 75 degrees. Well, sine of 75 degrees, you could create 75 degrees by saying that's half of 150, or you could say it's 45 plus 30. It's your choice. I'm going to write it as 45 plus 30. So I'm going to write it as the angle 75 degrees as the sum of 45 degrees and 35 degrees and 30 degrees. Yes, you could have grabbed a calculator, but I like this idea that you could just do things by hand. Let's suppose this was an exam and your instructor doesn't allow you to have calculators, and they say, find the exact value of this by hand without a calculator using methods taught in this course, right? So, of course, you have to, off to the side, multiply 16 and 24. Well, that's 4 to 12, 14, and then 2, 4. So a quick summation gives you 384. Great. So I know this is going to be 384 as a coefficient. And then the sum of angle formulas for the sine, it would be sine of 45 degrees times the cosine of the second angle, 30 degrees, plus the sine of 30 degrees cosine of 45 degrees. And at this point in trig, you should know all those special angles without me having to draw things. So this is going to be 384 times 1 over root 2 and times root 3 over 2 plus 1/2 times 1 over root 2. And that'll be 384 times root 3 plus 1 over 2 root 2. That's pretty good. That's the area by hand. Not bad, right? So that's something you could be expected to do in your class. I don't know. I don't know your instructor, but if you're one of my students, I could totally ask you to do that in a class. Anyhow, that's the only example I have for the area. And obviously, if you're allowed a calculator, grab a calculator and compute that. But if you're not, practice your sum of angles formulas or your half angle formulas. They'll give you the same answer.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.